Hello students, welcome to the EPG Pathshala. My name is Dr. Rajeshwari Sinha and in today's lecture we are going to learn about sampling techniques in biostatistics. This topic will be covered in two modules. This is the first module of the two. Let us see what objectives we are going to address in this lecture. We will learn about sampling for statistical analysis in a population through the following objectives: understanding the different sampling in statistical analysis. We will look at how to determine sample size for a study and different types of sampling techniques. Lastly, we will also look at some principles of sampling techniques. We hope you have an enjoyable time listening to this lecture. This slide shows the concept map that we are trying to follow in this lecture. Under sampling techniques, we are first trying to understand what is population and sample, wherein we will also look at the concepts of precision and neutrality, sample size determination, and pros and cons of a sample based analysis. We will also see why we need sampling, objectives of sampling, and some different types of sampling techniques. Lastly, we will look at the principles of sampling. Population and sample. Population refers to a complete set of elements that share a common characteristic and is of researchers' concern. A subset of the population is referred to as a sample. To elaborate still further, we may define a sample as a collection of individual the data is collected from a sufficiently large representative of the population under study and it is chosen by a standard sampling technique. This process of partial enumeration is known as a sample survey. The population must be clearly defined before drawing a sample. Statistic and parameter. The numerical value or descriptive characteristics recorded for the sample observation is known as a statistic, whereas when used to describe the characteristics of a population, it is referred to as a parameter. A value calculated from the defined population such as mean, standard deviation or standard error mean is called a parameter. It is a constant value and covers all members of the population. On the other hand, a value calculated from a sample is called a statistic such as mean, standard deviation. Sample statistics help us to draw inferences about population parameters. The value of the population parameter is constant but is usually unknown. On the other hand, the value of the statistic is known because it is computed from the sample. Observations differ from one sample to the next. Consequently, the value of the statistic varies from sample to sample. A representative Hence, its statistics are almost equal to the parameters of the entire population except for the chance difference, which can be reduced but not eliminated. Population may be an entire group of defined persons such as all members of household, women of 15 to 49 years of age, all infants in the community or village, under 5 years of age children in city about whom information is required. Precision and reflect the actual values for the population, that is, the accuracy with which population parameters have been estimated. Larger the sample size, more precise is the measurement. Mathematically, precision can be represented as follows. Precision equals to root over sample size divided by standard deviation of the sample. In order to attain twofold increase in precision, the sample size needs to be increased 4 times. Neutrality, on the other hand, refers to the absence of bias in any sample drawn from the population. Ideally, an appropriate sample is one that is devoid of any bias and possesses all the representative characteristics of the parent population. The differences in characteristics of sample and population, if any, ought to be negligible. One way to avoid bias is by evolving a bias-free study design. When dealing with human subjects, a single or double-blind study takes care of the bias problem to a large extent. When dealing with other living organisms, triplicate sampling helps to avert bias to a large extent. That is, it determines the probability of making a type 1 error alpha, generally at 0.05 or 0.01, and lastly the power of a test, that is the desired power of a test, which describes as the likelihood of finding a true significance result. How to determine the sample size? For the determination of a sample size, the following methods are recommended. The first one is for quantitative data. If the standard deviation of the population sigma is known from past experiences or records, then sample size can be determined by the following formula with the desired permissible error E at 5% risk. That is, E is equals to 2 sigma by root n, from which n comes to be 4 sigma square by E square. Here n is the sample size, sigma is the standard deviation and E is the margin of error. If E is equal to 1 and sigma square is equals to 100, then n is equals to 400. In case population standard deviation sigma is not known, a pilot survey or partial enumeration has to be carried out to estimate the sigma. For qualitative data, in this type of data, we deal with proportions such as morbidity rates, for example prevalence or incidence rates, and cure rates. The adequate sample size can be calculated by the formula given below with the desired permissible error at 5% risk. In such data, the permissible error should not be 20% of the positive character. Sample size n is given as 4pq by E square, where p is the positive character, q is 1 minus p or 100 minus p, E square, and E is the permissible error of p. Pros and cons of a sample based analysis. While by and large science is driven by sample based analysis, there are some facets that a researcher needs to consider and be aware of before initiating one. Sampling results in a great economy of effort, time and money. Wherever it is not possible to study the whole population, a sampling method can be employed. Sampling method is more scientific and can be applied to the population with more confidence. However, information about every item of the population cannot be obtained by this method. Since sampling techniques are based on the theory of probability, hence only those who are well versed in the theory of probability can use these methods. Faulty methods of selection would make the sample fail to be a true representative of the population, and the whole exercise can become a waste. Finite and infinite populations. According to the number of items in the population, it may be differentiated as finite or infinite. For example, the weight of all students of a college form a finite population, while the pressure at various points in the atmosphere forms an infinite population. Students, we have now reached midway into this lecture. In the next section of this not be tested for its quality. Only a few cans of salmon selected at random can be tested. Case study 3. In pollution studies, while testing for air and water quality, only a small portion of the whole is available for testing. Hence, in this situation, sampling method alone is practicable. Case study 4. In taxonomic studies, for the purpose of classification, if a characteristic of a large population is summarize what we have learnt in this lecture briefly. Population refers to a complete set of elements that share a common set of characteristics and is of a researcher's concern. A subset of the population is referred to as a sample. The numerical value or descriptive characteristics recorded for the sample observation is known as statistic, whereas when used to describe the characteristic of a population, it is known as a parameter. Precision refers to the accuracy with which population parameters have been estimated. Neutrality, on the other hand, refers to the absence of bias in any sample drawn from the population. A suitable sample size depends on three components, which is the effect size, the significance level and the power of a test. The process of drawing a sample from a population is called sampling. The objectives of sampling are twofold. One is estimation of population parameters from the sample statistics, and the second is to test the hypothesis about the population from which the sample has been drawn. Sampling techniques are two kinds, probability based and non-probability based techniques. The principles of sampling are again based on two laws. One is the law of statistical regularity and the law of inertia of large numbers. Sampling results in a great economy of effort, time and money. Only those who are well versed in the theory of probability can use these methods. Faulty methods of selection can make the sample fail to be a true representative of the population. Thank you for watching this lecture on sampling techniques in biostatistics.